we've got the formula for annuities, and in this formula, here's what everything is. R, right, this is the amount of money that we're going to put into our investment, maybe, every month, at the end of every month, or at the end of every year, or at the end of every week, just at the end of every time period. And lowercase r, that's the interest rate per year. M, that's the number of compoundings per year. T is the number of years that we're going to run this annuity. So suppose we do this. Let's put in, say we put in $200 at the end of every month. So M is going to be 12 because we're going to do this monthly. And suppose we leave it there for 10 years and we get an annual interest rate, say, of 4%. So what we're going to do is we're going to put $200 in to begin with, go 1 month. It'll make interest on that, and then that interest will be reinvested, and we'll get it again, all the way up to 10 years. So let's just substitute these numbers in to our formula, and we will get the future value of our annuity is, it's going to be 200 times the quantity, 1 plus 0.04 over 12, raised to the 12 times 10, 120 payment periods, minus 1. All that gets divided by R over M, which is 0.04 over 12. We just need to get our calculator or Wolfram Alpha to do this. So if I do it on my calculator, I'm going to put in this 200 parentheses, and then parentheses again, 1 plus 0.04 divided by 12, raised to the 12 times 10, close that, and then minus 1. Then I'll close the top. Right, let's match these up. I've got that one, and that one. That one closes, the last one closes the top, divided by, now I got a division here, so I need parentheses here, 0.04 divided by 12. So my calculator shows me that the future value here of this investment is $89,149 and 96 cents. Now, what if we had done this? What if we had just taken, I'll do it up here at the top, what if we had just taken our $200, put it into the account, not an account, just put it in a box, say, at the end of every month. We do that for 12 months, but then we do that for 10 years. So we're not making any interest. We're just taking our $200, putting it into a box, no interest, leaving it there at the end of every month, and we do that for 10 years. So that comes out to $24,000. So if we had just saved the $200, at the end of 10 years, we'd have $24,000. But if we can get this account here that we were talking about, where if we can get 4% interest and put this $200 in at the end of every month, at the end of 10 years, we'd have $89,000. And just out of curiosity, if we make this division, this is going to come out to be about 3.7. So if we make the investment, we're going to get about 3.7 times as much. Right? Can you read that? It's 89,149 is equal to 3.7 times the 24,000. So if I just read the language, it says that our 89,149 is 3.7 times just putting it into a box. Let's do one more example. Suppose that, say you can put in $1,000 a month, and we're going to do this for, say, a 35-year career, and suppose that we're going to get 6% interest. We're going to do this every month. How much would we have at the end of that time period for our retirement, say? So let's say the future value is then going to be 1,000 times, 1 plus 0.06 over 12, raised to the 12 times 35, for 35 years, minus 1. And all of this is going to get divided by 0.06 over 12. So again, a calculator problem. So I'm going to put into my calculator like this, 1,000 and then parentheses, that parentheses is that one right there. And then this one, this will be the other parentheses. Parentheses 1 plus 0.06 over 12, close. and that parentheses is that one right there. Raise that to the 12 times 35. Now your calculator, you may not have to do this parentheses. It may just bring you right up there. The newer ones do. I got an old machine. And then minus 1, close. Now that close, that's this parentheses right here. And if we match them up, just to be sure, just match them up. Those match, and those match. Then we're going to divide the whole thing by parentheses, because I got an operation down here, 0.06 divided by 12, and close it. All right, so I got a future value here of 1424710. I'll round off to 30. So comma, comma. So the deal is this: if we take $1,000, put it into an account at the end of every month at 6% every month for 35 years, how much are we going to have at the end of that 35-year period? Well, we'll have $1.4 million. Now, just so we know, what if you had taken that $1,000 and you just put it in a box at the end of every month, right, for 12 months? That's how much you'd have for a year. Multiply that by 35. So at the end of 35 years, how much are we going to have with no, just putting it into a box, no interest? Still comes out to a nice amount, $420,000, but it's not anywhere near that $1.4 million. In fact, if I take that 1,424,710, forget the 30 cents here, and divide it by 420,000, this will tell me how many times bigger the 1.4 million is than the 420,000. And that comes out to about 3.39. Oh, let's just say it comes out to about 3.4 times as much.